In this video, we shall be looking at projectile and solution in it. We shall be looking at the critical initial condition, and we shall be looking at all that it entails. Please relax, learn all about projectile. Please subscribe, like, and share. In this video, we shall be looking at projectile motion. We shall be looking at the calculations in it, and we shall be looking at the initial condition and how to be able to find our way around it. When we have projectile motion, we have horizontal component and vertical component of the initial velocity, and we need to understand this. And if you look at what we have on the board, on the vertical axis, the horizontal component of the velocity is u sin theta, and on the horizontal axis, the component of the initial velocity is u cos theta. This we'll be looking at in the more closely, and then our maximum height will be from this point down to the initial takeoff point. Then our range will be from this point to this very point. That's what will be our range. But this range is simply the distance on the horizontal axis. So in this video, we shall be looking at the following. We'll look at the secret of projectile itself. Then we'll look at the initial conditions. That is all the conditions, what we need to note, and how with this initial condition we'll be able to resolve so many things about projectile. The resolution of forces is very important. Then how do we resolve the force? How do we get u sin theta for the vertical, and how do we get u cos theta for the horizontal? This can equally be called v naught, that is the initial velocity. We call it v naught sin theta. What we mean by that v naught sin theta is the initial velocity, and u can also represent our initial velocity. These two equations are the same. Then useful equation, that is Newton equation of motion, the two important equation of motion in the calculation or in solving projectile problem. Then we look at our initial velocity on the vertical axis and our initial velocity on the horizontal axis. This will be our initial velocity on the vertical axis, and this will be our initial velocity on the horizontal axis. Then the time taken to get to the maximum height, for those of us who may not really want to bother ourselves with how to get how to derive the equation or how to be able to solve the problem without cramming equation. If you want to just know the equation, this is what you need to know. For the time taken to get to the maximum height is just u sin theta over g. Then the total time of flight is by multiplying this one with 2. That's why we have 2u sin theta over g. Then maximum height, when we are looking at the maximum height, as we said at that time, our maximum height is something like this. So we are looking at this distance is our maximum height. This is our maximum height, and that will be y max. And the formula to get that is u square sin square theta over g. And please note, when you are finding sin square theta, if I have sin 30 degree and I'm finding sin square theta, I will also find this, what is sin 30 degree, before now squaring it. It is not that you will square 30 degree and now find the sine. No, it is sine square 30 degree. So after you have found the sine, then you now square whatever value that you have. Then the range, that is the distance on the horizontal axis. Y max is the distance on the vertical axis. So range is the distance on the horizontal axis, which is u square sin 2 theta over g, or 2u square sin theta cos theta over g. Either of these two equations will give us the range. Then the maximum range for any given velocity This will happen when the whole of this expression is equal to 90. And when will this expression be equal to 90? It is when theta itself is equal to 45 degrees. So we can have our maximum range when theta is equal to 45 degrees. Then the resultant velocity at any instant of time, at a particular time. And the only one that will be changing is Vy. And that my V at a particular time will now be equals to V y square plus V x square. Then you find the square root. That is the velocity at an instant of time. And what will keep changing in that regard will be this Vy. If I say at time t is equal to 1, this V1 will change. So my velocity at that time, resultant velocity will change. V at t is equal to 3, V at t is equal to 4. My Vx will be the same, but by the time we add it together, we find the square root. Then we have V at that instant. Then angle of projectile at any instant, that will be Vy over Vx. That at any instant again, if it is Vy at t1, V1 at t2, V1 at t3, so we can get that Vx will always remain the same. Then from there, we can know what is our angle of projection at any instant of time. What we have in this place is for those people who don't really want to bother themselves about maybe difficult question, or who don't want to bother themselves about how to be able to have the full mastery of projectile. So you can just note the equation when you see any question, and if you are good, you can cram very well, you know it offhand, then you can be able to apply it. But there are some questions that you will not be able to apply the equation to directly, and you need to work it from the first person, though they are few in number, but that will make a difference between outstanding students and just an average student. And the purpose of this video is to make you an outstanding student. So these are part of our initial condition. Acceleration due to gravity is always directed downward, and it has no horizontal component that is on the vertical. You know, we have my acceleration is always directed downward. The acceleration is always directed downward because it's acceleration due to gravity. And on the y-axis, the acceleration is minus g, the acceleration on the y-axis, because the body is moving up and there is a velocity that is taking it up. And by convention in physics, if u is positive, then v or g, if v or u is positive, then my g will be negative. So in this scenario, there's a velocity taking it up against gravity. Because it is working against gravity, so my g will be negative. But on the horizontal, there is no acceleration. But on the vertical, we have acceleration because it will be changing as it's moving. The acceleration is constant on the vertical, but on the horizontal there is no acceleration. So three things is very important in this case. We have acceleration. The acceleration is on the vertical, it is constant, and it is negative. On the horizontal there is no acceleration, and the acceleration on the horizontal is 0. Then to work our way through projectile again, we need to know that these two equations of motion, they are very important in the calculation of projectile, and this will be my velocity at a particular time. If I'm on the horizontal, my a is 0, so it means my velocity on the horizontal, which is v of x, will be equals to u cos theta. And if I'm looking at my velocity at an instant of time on the y-axis, it will be vy is equal to this u now will now be u sine theta, because I have acceleration on the vertical. So, and my acceleration on the vertical is minus g, so minus g t. This is the velocity at an instant of time. Then we can do the same for our distance, which we will do later. So if the velocity at the long time is u, it can also be referred to as v naught. Initial velocity at the horizontal axis is u cos theta. That's why I'm bringing my initial velocity to this place now, u cos theta. That's on the horizontal. Then my initial velocity on the vertical is u sin theta. That is why I'm bringing this. This is my initial velocity. But if I now want to find my velocity at an instant of time, then I'll put minus gt. At an instant of time for on the horizontal axis will just be u cos theta, because g itself on the horizontal is 0. So how do we do resolution of forces? This is what we need to note. It's very important. This is resolution of forces. I'm assuming that my projectile is going in this way. This is my theta. So let's look at the resolution of forces. If I have so this is my y-axis, this is my x-axis, and if you look at this is my theta. So we can use our saw, car, then tour. So I want to see what is the effect of this. I have this f now. Let's now say it is my initial velocity. So I want to say what is my initial velocity on this horizontal axis, which will be ux instead of this fx, and on the vertical axis of fy it will be uy. So to know, this is my 90 degree, this is adjacent, this is opposite, this is hypotenuse, and I want to know what is my ux. So it is adjacent and already know my hypotenuse. So adjacent and hypotenuse will give me cos theta. So I can now say cos theta is equal to adjacent. What is my adjacent? Ux. What is my hypotenuse? That is my u. So ux, which is the initial velocity on the horizontal axis, is now my initial velocity cos theta. And similarly, my uy will be equals to u sin theta. What we have is just initial velocity on the horizontal axis, initial velocity on the vertical axis. Because if I want to find this second one, it will be sin theta. Sin theta is equal to, sin theta is opposite over hypotenuse. What is my opposite? My opposite is my uy that I'm looking for. Uy over what? Over hypotenuse, which is u. So u sin theta will give me uy. This is the velocity, initial velocity at the horizontal, initial velocity at the vertical axis. This is not velocity at an instant of time, but this is very handy. We need this in whatever calculation, derivation, or whatever you want to do. If you know this, you don't even need to memorize any formula, and you know this. If you know this, then you can apply it to this equation and apply it to this equation. You don't need to cram any formula. Just put them into this equation, you get your answer. So that is how to resolve. This is my u, and this is my uy, and we have my ux. I can now find my vy at an instant of time. I can find my vx at an instant of time. So if you now look at this, we have been able to look at the initial condition, which is the velocity on the vertical, the acceleration on the vertical axis is minus g, and is directed downward, and it is constant. The acceleration on the horizontal is 0. So with this, we are okay with that. Resolution of forces, we know that ux, that is the initial velocity on the horizontal axis, is u cos theta, and the initial velocity on the y-axis is u sin theta. So we are moving now to the useful equation. So if you look at this equation, as we have said, they are very, very important in whatever we want to do. And this is the equation that we shall be using for all the calculations that we have in this in whatever we want to do in this projectile. So to calculate with this equation now, we can look at, since we said that ux is equal to u cos theta, and we say u y is equal to u sin theta. So if I now want to know what is my, from the two equations now, I know that v is equal to u plus 80. This first equation is telling me my final velocity, or velocity at time t. So I can find what is my velocity at time t on the y-axis, velocity at time t on the x-axis. So v y will be equals to, so this is my initial velocity, which will come to this list because I'm doing for uy now. So it will now be u sin theta, because initial condition has stated that, in the initial it has been stated that acceleration on the vertical axis is g, and it is minus, so we have minus gt. So with this, if we are asked to calculate the velocity at the vertical axis when t is equal to 1, just put 1 into this place. When t is equal to 0, then we have it to be u sin theta. When t is equal to 2, you can get it. When t is equal to 3, you can get it. Then my vx will be equals to, I will bring the ux to this point. And what is my ux as my initial velocity? That will be u cos theta. So I use cos theta. I will now go to 80. What is the acceleration on the horizontal? Acceleration on the horizontal is 0. So this will be plus 0 times t. So it will now be equals to u cos theta. So in the horizontal, this initial velocity is not changing. You can see the t is 0, but the final velocity is not changing on the horizontal, but on the vertical it will be changing with respect to this. Once this, the only thing that can make this to change is if this theta, if we are varying this theta. If this theta is not varied, u is constant, then our velocity, final velocity on the horizontal will be the same. And that is the reason why acceleration is 0, because acceleration is dv dt. Because the velocity on the horizontal is not changing, that is why acceleration is 0 in this place. Or because the acceleration is 0, That's why the velocity is constant. But in this place, acceleration, the velocity is changing. The velocity is changing in this place. So final velocity will keep changing. Because by the time you multiply it with t, then we'll have different value. The other thing we need to know is our resultant velocity, which is the v. It will equals to v y square plus v x square. Then you find the square root. So this v will be equals to, what is my vy? My vy is u sin theta minus gt whole squared, then plus u cos theta all squared. Then you can find the square root. So then we can still find the direction as well. We can find the direction, which will be tan theta, which will be equals to v y over vx, and that can be derived from the former equation. So let's look at time to get to the maximum height. Time to get to the maximum height. We will get that from v is equal to u plus 80. At the maximum height, at this maximum height, the final velocity, the velocity has been increasing. When they get to this point, it will now be 0. Then gravity will take over. It is gravity that will now be in control from this point. So at that particular time, then my final velocity will be equals to 0. So I can now say 0 is equal to this u, because we are still considering it on the vertical axis. It will now be u sin theta minus gt. So if you make t the subject of the formula, so t will now be equals to u sin theta over g. So this is the time taken to get to this maximum height. As it take off from this place, the time it took to get to this maximum height. So this is half of the journey. It has taken this to get to this place. To get to this other place means if I multiply this with 2, I will be able to get the time taken for this other part. So this is 1 and 1, so 2. So my t, this is t maximum. Then total time total. If I multiply the above by 2, that will be 2u sin theta over g will give me total time. So we have been able to look at total time, and we have been able to look at time taken to get to the maximum height. So we have been able to look at this time to get to the maximum height. This one is total time. This is not maximum time. This is maximum time times 2. But this, we can just write this as t total. So t total will now be equals to 2u sin theta over g. So we can now look at, let's now look at maximum height in itself. And I said, note, you find sine theta first, then you square the value. If you find sine theta first before you square the value, it's not like you will square. If I have 30 degree now, you cannot say 30 degree square. You now find sine the 30 degree that you have squared. So you need to find the sine theta first. Whatever answer you have gotten, then you now square it. You can find u square, then 2 divided by g. How do we arrive at this equation for this fourth part? So you know, because we are talking about distance to the maximum height, then we take the second equation of motion. This equation of motion that says S is equal to ut plus half a t squared. So since this S now, I'm talking about y axis now, I can say y maximum, that is the distance to the maximum height. That is, I have something like this. I want to know what is this distance. So since we are talking about distance, we can use this equation of motion. And since the distance we are talking about is on the y-axis, then what is my initial velocity on the y-axis? Don't forget, y is equal to u sine theta. That is my initial velocity. So which is this u? So I can say u sine theta, then times what is t? T is the time to get to this maximum height, which we did the other time from v, is equal to u plus at. I will say this one was 0. I will put this one as u sine theta minus gt. So I can get my t to be equals to u sine theta over g. So this is time to get to the maximum height. So I can carry the whole of this and bring it to this place. So it will now be u sine theta over g. Then because this a will now be my g and it will be minus, so minus g over 2. This u now I will now square it, because this t I will square it. It's still the same t to get to this time. So it will now be u square, then sine square theta over, because I have g there, that will be g square. So this g will definitely cancel this g. So I will now have my y max to be equals to u square sine square theta over g minus 1 over 2 u square sine square theta over g. We can find the LCM to be 2g. So if I have 2g, how many 2g do we have here? 2. That is 2 times, so this will be 2 u square sine square theta, then minus minus. So you can make 2g the subject of the formula. We have u squared sin squared theta over g minus half u squared sin squared theta over 2g. So we make 2g our LCM. Then how many g do we have in 2g? That's 2. 2 times u squared sin squared theta will be 2u squared sin squared theta. How many 2g do we have in 2g? 1. 1 times u squared sin squared theta, so it will give me u squared sin squared theta. So 2u squared sin squared theta minus u squared sin squared theta, this one will be equals to u squared over 2g. So my y maximum is equal to u squared sin squared theta over 2g. So this is the distance to the maximum height, and the calculation was done from this equation of motion ut plus, and even if under examination condition you don't need to derive the equation, you can put in the value of your initial velocity that you have been given. Let's say we are giving u here to be 20 and this theta to be 30. Just put in this place to be 20 sine 30 degree, then times 20, then sine 30 degree over 9.8, then minus this, since we have half gt squared, this will be 9.8 over 2. This u square will be your 20 square, and this sin square theta will be sine 30, then you square whatever value you have, then divided by 9.8 square. Then with that, you don't even need to come to this place and start using the equation. But if you are good in memorizing and you can remember the equation offhand, then you can go ahead with that. So let's look at, we have been able to look at this initial condition, which is g is equal to 0 on the horizontal, g a is equal to minus g on the vertical. On the horizontal, a is equal to 0. Then resolution of forces, u of x, initial velocity on the horizontal axis, that will be u, initial velocity cos theta, and then on the y-axis, uy will be equals to u sine theta. This is the initial velocity. Then when we are now saying what is the velocity at time t, we have explained that. You can go back to the video and check that. Then time to get to the maximum height, we have been able to explain this. That is when from v is equal to u plus a t. That is when this v is equal to 0 at the maximum height, then I can bring my initial velocity on the vertical axis, which is this. I can bring it to this place, and this will be minus gt. Then we have done this. We have done for the maximum height as well. We want to look at the range now. So we have done all this. All this has been taken care. So we are left with this now. We want to look at this. So if we look at what is now my range, so we come back to equation of motion, because range is talking about distance from this place to this place. This is my range, or you can say distance on the horizontal axis. This place to this place is maximum height, or you see distance in the vertical axis. So I will use S is equal to UT plus half AT square. So on this horizontal, without wasting time, my acceleration on the horizontal is what? It is 0. So the whole of this expression is what? Is 0. The whole expression in that place is 0. Then what is my initial velocity on the horizontal? My initial velocity on the horizontal, ux, is equal to u cos theta. What is my t on the horizontal? This is total time. Don't forget that we find the time at this point and the time at this point, and we find the time for the two of them. That is my t total, tt, will be equals to 2u sin theta over g. Just bring these two equations together, then you get your range. So my range will now be equals to, what is my ux? That is u cos theta. This is theta, this is not t, this is theta, cos theta. Then times t, which is the total time, because the range covers the total time. The range covers the total time of the flight. Then times 2u sin theta over g. So my range now will now be equals to, so I can say I have u square, then 2 cos theta sin theta over g. You can look at this very well. And if you look at trigonometry identity, if I have sine A plus B, it is equals to sine A cos B plus sine B cos A. If I now have sine theta plus theta, which is equal to sine 2 theta, because this theta plus theta will give me 2 theta. So I can now write this sine theta plus theta as sine theta, then cos theta, then plus sine theta cos theta. But this is now my A, this is my B. But it's like I have AA, or I have BB, or I have theta theta. So this one will now be equals to sine 2 theta will now be equals to 2 sine theta cos theta. So this is 1 and this is the second one. So 2 sine theta cos theta, And if you look at where we stop, this is where we stop. This one is just for explanation to know what we are to do to this equation. This is cos theta. So the whole of this, I can replace it with sine 2 theta because they are the same. So I can now say my range is now equals to what? So it will now be equals to what? It will be equals to u square sine 2 theta everything over g. So this is my, why we are trying to implement this identity is so that we can have these 2 theta. So that we can have these 2 theta. And if you look at this 2 theta, when sine theta is equal to 1, when sine theta, when it is equals to 1, then we have maximum range. And when will this be possible? When 2 theta, when it is equal to 90. So when 2 theta is equal to 90, or you can say theta is equal to sine inverse of 1, and you get it to be, so our theta, you know, let's what we are trying to do in that slide now is we are now working on this. That is, when do we add this to be maximum? Then we are saying, you know, already we have derived that my xx is equal to u square then sine 2 theta is over g. When sine 2 theta is equal to 1, then u square over g will be maximum, because the value of this sine 2 theta will be reducing the value of u square. But when this sine 2 theta is equal to 1, then we can have this xx to be maximum. And if I say sine 2 theta is equal to 1, it means 2 theta is equal to can you find what is sine inverse of 1? So this will be equals to sine inverse of 1 will be equals to 90. So if you divide both sides by 2, it means theta, when it is equal to this 1, it is equal to 45 degree. Is equal to 45. So for us to have maximum range, it will be when theta is equal to 45 degree. Number 7, we have tried to explain this in the course of the slide, so I don't think we need to go over this again. We know that resultant velocity at any instance of time, v of y is u sin theta minus gt on the vertical axis, and ux is equal to u cos theta. And we can now say v is equal to, put your vy in it plus v what? Vx, and then you can find the square root. That is, you square this and you square this, and then to find the angle of projectile at any instant of time is simply you can say it is vy over vx, and the vy, this is what you are using as your vy, and this is what you are using as your vx. It will give us the value of our angle of that projectile at any instant of time. So we can look at this equation, you can copy it and try to solve them. Solve this question one after the other. A footballer kick a ball at a speed of 39 meters per second at an angle of 54 degrees. What is the position of the ball at t is equal to 4 seconds? What is the position of the ball at t is equal to 4 seconds? Find the magnitude and direction of its velocity at t is equal to 4 seconds. You can see because of these 4 seconds, you cannot just pick the equation and use it. So it means you need to apply this 4 into the equation. Let's just see what you can do. You can put your answer in the comment below, and I will attend to them and look at your answer if they are correct. And if you have any question, you can let us know. Then we'll look at how to resolve those questions. Then what is the maximum time to reach the maximum height? This one you can easily do. Also, what is the distance to the maximum height? This one you can easily do with the equation. Then with this one, you need to use the understanding of what we have done. For this A, you need to use it. For this B, you can simply use equation. What is the horizontal range? That's what we just did. What is the maximum range for this velocity? You just say your v square over g. You know, we have been given the velocity. Just find the square of this, then divide it by g, because the theta will be will give us 1. If you put the theta in it, it will be v square sine 2 theta over g. Then it means your theta should be equals to 45 degrees. We are no longer using this. If you are looking at what is the maximum range for this this velocity, so just try and look at what you can do in this equation and resolve all the questions you can resolve. Whichever one you cannot solve, just let us know in the comments below, and then it will be attended to. Thank you for your time. Thank you for your attention. See you in another video. Please like, subscribe, and share.